Okay, so I'm working on a previous exam 3 from the spring 2019, and this is to review for the fall 2019 exam 3 in math 2144 calculus 1 at Oklahoma State University. All right, so here I'm given a rate function that tells the rate of growth, and I want to know the net change in weight. And so essentially the theorem that we want to be applying here is that the integral of some rate function is the net change. So we should have a feeling that if I want to find the increase in the child's weight, that I want to be integrating this rate function. And so if I look at these, the two that involve integration are this one and this one. I can see this one goes from 2 to 5, this one goes from 5 to 2. So this is the bounds are in the wrong order. So it's looking like A is the correct answer. Let's look at the other answers just to see if we can make sense of them. This one is the change in the rate of change. So g prime of 5 minus g prime of 2 is nothing close to an integral. I look at D, this is the average rate of change of the rate of change. So this would be an approximation of G double prime, which is not at all what we want. And then this here almost looks right. It kind of looks like the fundamental theorem of calculus a little bit, except that it's the derivative of G prime. So again, that's going to be dealing with G double prime, which is not what we want. If I look at number 2, I'm given, again, a rate of change function, and I want to approximate the value of the stocks from 4 to 7 months after the stock was purchased. So, all right. So if I want to evaluate the rate of change of the stock, I want to be looking at how much the stock is worth on these different intervals. So if I'm going from 4 to 7, I want to divide that into rectangles, right? So, and then what I want to do is on each of those intervals, I want to compute the value of the stock. And so essentially I want to do some rate of change of the stock multiplied by some delta t, or some change in amount of time. So if I look at this first one, it looks like I have some g of t, and it looks like here like the delta t is equal to 1. So it looks like I'm going to be dividing. If I'm dividing it into rectangles here, then I should have 1, 2, 3 rectangles. But if I look at this, the problem is it starts at k equal 4 and it stops at k equal 7. So that's going to give me actually too many sample points, because I really want just 3 sample points. So this is going to be g of 4 plus g of 5 plus g of 6 plus g of 7. So that's acting like I have 4 rectangles when I really only should have 3 rectangles. So that's why this one is not correct. It would be correct if it stopped at 6 or started at 5. But since it has kind of 4 values there, then that will not work as an approximation. The next one looks almost the same, except it multiplies by this random delta t, but it doesn't tell us a value for that delta t. Again, so this is not correct, because we really want to know what is that delta t. So it's kind of like, yeah, so that's not giving us what we want. This next one looks interesting because I have this, I'm evaluating the rate function, and then I'm multiplying by, this looks like my delta t is equal to 0.5. Okay, so let's think about that. So if that were 0.5, then I'm dividing it into rectangles of width 0.5. And so let's see what happens when I plug in different values of k. So if I'm going to evaluate this, that's going to be, if I plug in k equal 1, that'll be g of 4.5 times 0.5 plus g of, if I plug in k equal 2, I'll get 5 times 0.5 plus g of 5.5 times 0.5 plus, and where is it going to stop? When I get to k equals 6, I'll have g of 4 plus 0.5 times 6, so it'll be 4 plus 3, so I'll have g of 7 times 0.5. So that is actually going to work because that's going to be a right-hand sum. So I'm going to be computing a right-hand sum here on this. Yeah, so that right-hand sum is going to work. So that actually is a possibility. Let's look at the next one. Again, I have this random delta t that's not defined, so we're going to cross that one out. And then this one actually is very similar to the first one, because if I start at k equals 0, I'll have g of 4 plus g of 5 plus g of 6 plus g of 7. And again, it's acting like my delta t here is equal to 1, but I'm taking too many samples of the function g here, so that's not going to work. So the correct answer is C. Okay, so on the next one, I want to find the value of this definite integral, and it's going to be equal to the value of which of the following expressions. Okay, so we're going to let u equal 2x, and in that case, that means that my du is equal to 2 dx. And so there are a couple ways of thinking about that. I can say that dx is equal to 1/2 du. So that will work. And then if I am going to write out this integral, I need to remember that these bounds here, this 0 and this pi, are x values. So when I write my integral in terms of u, I need to convert those x values into u values. So if x equals 0, that means that u is equal to 2 times 0, so u is 0. And if x equals pi, then u is going to be 2 times pi, so u is 2 pi. And so my integral should be from 0 to 2 pi, and now I'm going to replace everything that involves an x with something involving a u. So I'll have cosine of u, and then dx I can write as 1/2 du. Okay, so let's see if that matches anything that I have over here. So this one has the wrong bounds. This one has the right bounds, and that 1/2 is moved out front. That's fine. This one has the correct bounds, but I have a 2 instead of a 1/2, so that's not it. This one has the incorrect bounds, and this one again, incorrect bounds, but that 1/2 is correct. Okay, so the answer is B. Next one, how many values of k in the interval negative pi over 2, so we're going from this spot to pi, that's this spot, satisfy this equation? The integral from 0 to k of sine of 4x equals 0. Okay, so let's see here. The graph of sine of 4x is given below. Okay, so if I'm integrating starting at 0 and going to pi over 2, so I know the integral from 0 to pi over 2 of sine of 4x dx will be 0 because that's this integral, and this part and that part are going to add to 0. Okay, I'll have that one more time. Integral from 0 to pi of sine of 4x will also be 0 because if I go all the way to pi, I'll have the same thing happen twice. And then I can do, if I go backwards starting at 0 to negative pi over 2, then I'll get 0 as well. Integral from 0 to negative pi over 2 sine of 4x is going to give me 0 as well. So there are 1, 2, 3 possibilities. The answer is D. Okay, last one on this multiple choice says that the integral from negative 2 to 9 of f of x is 12, and the integral from 3 to 9 of f of x is 4. And it asks for the integral from negative 2 to 3. I'm just going to draw a number line, put all these things on here. And so I know that the integral from, okay, so I know that the integral from negative 2 to 3 of f of x dx plus the integral from 3 to 9 of f of x dx should be equal to the integral from -2 to 9 of f of x dx. Okay, I have a value for this one. So this is equal to that one. And I have a value for this one, which is that one. And then this is the one I want to find. Okay, so all I do is plug in the values. So integral from -2 to 3 of f of x dx plus 4 is equal to 12. So I can subtract the 4, and I get that the integral from -2 to 3 of f of x dx is equal to 8. So I'll put that there. Okay, we skipped problems 2 and 3 from that previous exam because they are not, that content is not covered on the exam for this fall. So, so we skipped problems 2 and 3 from this because that content is not on the third exam for the fall 2019. Okay, so we're just going to skip those 2 problems and we'll go on to problem 4. Okay, so it says the table below gives the rate at which a mayoral candidate is gaining votes T days after she announces candidacy. So assume that the rate at which the candidate is gaining votes is increasing for the first 32 days. And assume that the moment she announces her candidacy, she had 520 supporters. All right, so it says use the right endpoint approximation with 4 equal width subintervals to approximate the total number of supporters after 32 days. Okay, so I have 32 and 0, and I want to divide that into 4 equal, so there I can divide it into 4 equal subintervals, and I want to use a right-hand approximation. So I'm going to sample from the right-hand side of each interval. So I'll use these 4 values. And so I can, all right, I can go from there. So, all right, so we can start with the 520 supporters that we had, plus in the first 8 days, we're going to assume that we were gaining 96 voters per day. So we'll do 8 times 96. Plus, in the next 8-day period, we're going to assume that we're gaining voters at a rate of 152 voters per day. And then for the next 8 days, we're going to assume that we're gaining voters at a rate of 287 voters per day. And then for the next 8 days, we're going to assume we're gaining voters at a rate of 449 voters per day. And so that should give me the total number of supporters after 32 days. Okay, so I added up that all up, and I got 8,176. So assuming I plugged that all in right, this is the supporters. Okay. Is your approximation in part A an overestimate or an underestimate? And so when I look at each of those 8-day periods, I can see that the rate at the end of the period is higher than the rate earlier on. And so what that means is that since I'm using that higher rate to do this approximation, what I have is an overestimate. Because the rate of voters gained at the end of each 8-day interval is higher than at the beginning. Okay, and then write an integral that represents the exact total number of supporters after 32 days. So that integral would be, we'll just say 520 supporters plus the integral from 0 to 32 of r of t dt. Okay, and so that would be the exact number of voters. Okay, next page, I'm just going to be evaluating these integrals. And so we'll go ahead and just compute antiderivatives for each of these. And so this is just like a polynomial, so I can compute the antiderivatives of this. And so I'll get 18 over 6 x to the 6th minus 10 over 5 x to the 5th minus 28 natural log x. And I'm just going to go ahead and put my plus c there because this is not a definite integral. So, so that is an antiderivative of that function. Okay, for the next, I do have a definite integral this time. I'm going to rewrite it as the integral from 1 to 3 of t to the negative 2 dt, just because then I can use kind of like my the power rule for antiderivatives. And so that's going to be t to the minus 1 over negative 1. So I'll just write minus t to the minus 1, evaluated from 1 to 3. And I can use the fundamental theorem of calculus there to just write that antiderivative evaluated at my endpoints. So I'm going to get negative 1/3 minus negative 1. So negative 1/3 plus 1, so that's 2/3. Okay, for the next one, I'm going to let u be equal to theta squared. And then my du is 2 theta d theta. So in other words, theta d theta is 1/2 du. Okay, so now I'm going to do my substitution. So instead of my theta d theta, I'm going to write 1/2 du. And instead of sine of theta squared, I'm going to write sine of u. And then since my theta d theta was 1/2 du, I can write that 1/2 out front, or you can write the 1/2 inside. Either way, it doesn't matter. So what is an antiderivative of sine? It's negative cosine plus c. And since my original integral was in terms of theta, I'm going to just write my answer in terms of theta as well. So instead of writing cosine of u, I'm going to write cosine of theta squared. And for the last one, I can see that this looks like the fundamental theorem of calculus part 2, except that instead of just a plain x, I have an x squared there. So I am going to have to invoke the chain rule when I take the derivative of this. So the fundamental theorem of calculus part 2 looks like you're just going to kind of plug in that x squared in place of the t's because I'm taking the derivative of an integral. So you're going to get x squared to the 5th minus 9 times x squared cubed. And all of that is multiplied by the derivative of x squared, which is 2x. All right, for the next one, we have the graph of f of t as given below. And then it just notes that that's a semicircle. We may use some geometry to do some computations here. And I want to define a of x by the integral from negative 6 to x of f of t dt. So what is a of negative 8 and a of 0? So a of negative 8 is going to be the integral from negative 6 to negative 8 of f of t dt. And so that's going to be the negative of the integral from negative 8 to negative 6 of f of t dt. And if I look at my picture, I can see that that integral, is going to be a triangle. That area is a triangle. And the base of that triangle is 2, and the height of that triangle is 4. So it's going to be negative of 1/2 times the base times the height. So this is going to be negative 4. And a of 0 is going to be the integral from negative 6 to 0 of f of t dt. And so I can see that that integral is going to be this area of this semicircle. So this is going to be equal to 1/2 pi times the radius squared, and the radius of this is 3. Okay. And then on B, it says, for what values of x does a of x have a local maximum? And so let's just think about this in terms of areas. And so if I'm starting at -6 and I'm moving to the right, I'm going to be collecting positive area here. And so a of x will be increasing as I move to the right. But then at 0, I'm going to start collecting negative area. So the area a of x is going to start decreasing again. So I know a of x will have a local maximum at x equals 0. And if I think about moving the other direction, hang on. So another way to think of it is I can think of it using the first derivative test, and I can look at what a prime of x is equal to. Now remember, if I take the derivative with respect to x of this integral, that just gives me f of x, right? And so if I look at f of x, when is a prime equal to 0? A prime will be equal to 0 when f is equal to 0, so here and here. So my critical points are -6 and 0. And so a prime of x is equal to f of x is positive when we are to the left of -6, positive when we are between -6 and 0, and negative here. And so what that means is that a is increasing here, a is decreasing here, and a is increasing here. And so my only critical point that's a maximum is at 0. So that's another way to think about it. This one says find a prime of 2. Again, we just said that a prime of x is equal to f of x. So a prime of 2 is going to be equal to f of 2, which we can evaluate here. F of 2 is -2. Okay, last page. So here's a graph of g of x, and then it says each of the things is a numerical value. Identify which of the following is the largest value and which is the smallest value. Okay, so let's start with g prime of 1. And so when I think of g prime of 1, that's going to be the slope of the function at 1. And so if I were just kind of computing that slope, it looks kind of close to +1. Something close to that, so it's some positive value. What about the integral from 1 to 5 of g of x dx? So that's going to be this area here. Integral from 1 to 5 of g of x dx. So that's going to be this area here, which that area is going to be clearly bigger than 1, because if I think about it in terms of square units, I can estimate, that it's, 1, 2, 3, 4, 5, 6, it's, close to 8 units, square units, approximately 8-ish, something like that. This is wanting the, this is a Riemann sum, and it is the Riemann sum starting at 1, and then I have 9, I've broken this up into, 10 rectangles, and so let me erase this here. And so for this one, I am looking at my delta t is, or my delta x is 0.4. So I'm starting from 1 and ending at 5, and I have broken this up into 10 rectangles. So let me delete this. So really I have 10 rectangles here. Yeah, so something like that. And then what I'm doing is I'm putting in the right-hand sum here to evaluate this. So this is a right-hand Riemann sum. And I know that because if I evaluate my first one, it's going to be g of 1 plus 0.4. So 1.4 times 0.4 plus. And then my very last one, if I plug in 10, I'll get 1 plus 4. So it'll be g of 5 times 0.4. And so if I look at this Riemann sum, it's a right-hand Riemann sum. And so since it's a right-hand sum, I know it's going to be greater than the interval. So this is greater than the integral from 1 to 5 of g of x dx. Because it's a right-hand sum. Okay, and then g double prime of 1 is going to be the concavity at 1, which is going to be negative. Okay, so if I want the smallest value, will be this, that's the only, g double prime of 1 is the only one that's negative, so g double prime of 1 will be the very smallest one, and then the very biggest one will be this Riemann sum.